So for this lecture, we are going to talk about some angles that are commonly found in trigonometry and where they terminate on the unit circle. When we talk about this, we're only going to talk about this within the context of being in quadrant 1. So what I want you to do right here is I want you to pretend that we are in quadrant 1 and that we're on the unit circle, so that this is centered about 0, 0. And remember, if we're on the unit circle, we know that we're starting at 1, 0, and that we are ending at 0, 1, again, just because we're hanging out over here in quadrant 1. Now, in regards to talking about this in radians and degrees, remember that the positive x-axis, which is what we're at over here, can be thought of in terms of degrees. We're at 0 degrees. I'll do those in purple. In terms of radians, we're also at 0 radians. I'll do those in pink. So in degrees, we're at 0. Let's do this. In degrees, we're at 0. And in radians, we are at 0 as well, and I'll do those in pink. Now, okay, so we are on the unit circle, and what we're doing is we are creating a circle of radius 1 that is going across the positive x-axis, or over here in quadrant 1. And we already know two ordered pairs that are on the unit circle, and that is 1, 0 and 0, 1. But there are a few other angles and the ordered pairs where they terminate at that occur quite often in trigonometry in quadrant 1. Now, the first angle I want to make sure that you're comfortable with, and we're going to start off, we're going to do these again in terms of degrees and in terms of radians. But the first angle I want you to be comfortable with is this angle over here. And we are going to refer to this angle as pi over 6. So if we have an angle that is pi over 6 radians, so sorry, I should be doing that in pink. If we have an angle that is pi over 6 radians, notice that it does terminate, or it does hit the unit circle at this point right here. And that point where it hits the unit circle, this ordered pair where it hits the unit circle, is the ordered pair square root of 3 over 2, 1/2. So if we travel pi over 6 radians, the point where it terminates on the unit circle is square root of 3 over 2, 1/2, and pi over 6 radians in terms of degrees. Now remember, to convert it to degrees, we could just multiply it by 180 over pi, and when we do that, that's the same thing as saying 30 degrees. So a 30-degree angle, or pi over 6 radians, will have a terminal point on the unit circle at the ordered pair square root of 3 over 2, 1/2. Okay, let's go on to our next angle. So here is another angle that tends to show up a lot in terms of trigonometry, and that is what this angle looks like over here. And this angle in blue is equivalent to saying pi over 4. So, oh, sorry, again, that should be in pink because it's in terms of radians. So that is pi over 4. And so for pi over 4, we are going to terminate right here on the unit circle, and this ordered pair corresponds to square root of 2 over 2, square root of 2 over 2. And if we wanted to convert pi over 4 into degrees, again, using that formula, we're going to multiply that by 180 over pi. The pi's cancel out. 180 divided by 4 is the same thing as saying 45 degrees. So that's equivalent to saying a 45-degree angle. And one more angle that tends to show up a lot in this quadrant is this angle over here. And where that angle hits the unit circle, we're going to call that bit over here, is this angle right over here. And this angle, this green one, that is equivalent to saying in radians pi over 3. I should make that a big pi over 3. And again, that pi over 3 is this guy. I'm going to write this down on a chart off to the side in a second. And where we terminate, or where we hit on the unit circle over here, is at the ordered pair 1/2, square root of 3 over 2. And then if we continue to go, we're over here where this ordered pair 0, 1 is. I'm sorry, let's go back to over here. Pi over 3 in terms of degrees is is equivalent to saying, well, again, multiply that by 180 over pi. The pi's cancel. 180 divided by 3 is 60 degrees. So these angles, 30, 45, 60, they should look familiar. These should have been angles that you played with before, maybe in Math 56, or you've seen somewhere along the line in some other case or circumstance. Now, if we continue, we're going to hit this angle over here, which I hope you can see is our 90-degree angle. So in terms of degrees, this angle is 90 degrees. And remember, in terms of radians, that's the same thing as saying pi over 2. So the important part are these ordered pairs where we terminate over here. We have these 5 ordered pairs. We already knew about the 1, 0 and the 0, 1, but now we're adding 3 more ordered pairs. Square root of 3 over 2, 1/2, square root of 2 over 2, square root of 2 over 2, and 1/2 square root of 3 over 2. Let's sum this up in a chart over here. I'm going to write the chart in terms of radians, in terms of degrees, and then in terms of their coordinates and in terms of their coordinates x, y, where they are terminating on the unit circle. So we'll put radians over here, we'll put degrees over here, and then we'll put where they terminate on the unit circle. So again, 0 radians, which is equivalent to 0 degrees, which is this point over here, corresponds to the ordered pair 1, 0 on the unit circle. The next angle we spoke about was pi over 6. Pi over 6 radians, which is equivalent to 30 degrees, terminates at the ordered pair square root of 3 over 2, 1/2. Pi over, next came pi over 4 radians. Pi over 4 radians is the same thing as saying 45 degrees. And that terminates at the ordered pair square root of 2 over 2, square root of 2 over 2. After pi over 4 radians, we have pi over 3 radians. And pi over 3 radians is equivalent to saying 60 in degrees. That terminated at the ordered pair 1/2 square root of 3 over 2. And then once we get to our 90-degree angle, in terms of radians, we have pi over 2, 90 degrees, and the ordered pair where that terminates at, well, that's this ordered pair over here, so that terminates at the ordered pair 0, 1. These are important. Keep this in mind, and this is going to help us to be able to determine a lot of information in regards to specifically what these radians or degrees are, or multiples of these radians or degrees as well. And we're going to look at some examples of these in a few minutes.